Hello everyone. Today I'm going to be giving an overview or summary of binomial expansion to higher powers. Now you should already be familiar with an expression like this one, a plus b all squared. You should know that to be a squared plus 2ab plus b squared, right? But when it comes to higher powers like this, it gets a bit more complicated. Now I'm going to be going over how to solve these. First of all, we want to look at how these powers are influenced by Pascal's triangle. This is what I've got an image of here, Pascal's triangle. Now, this is a very interesting combination of numbers because, here I'll do this in a different color. These numbers all add to the next number. So 1 plus 2 obviously equals 3. And all of these equate to a different power going from 0 to the, in this case, the one I have here. This one goes down to the 7th power on this row, right? That can be shown, each power is also related to the first number after the 1, shown here, okay? So how does this work with binomial expansion? Well, we can see here that if we go to the 3rd power, this row being the 3rd, the 0, 1, 2, 3rd row, we can see 1, 3, 3, 1. Now, what does that have to do with this expansion? Well, here we go. The expansion of this ends up being a cubed plus 3a squared b plus 3ab squared plus b cubed. Now, if you imagine there's a 1 in front of both these pronumerals, you can see that these here work in conjunction with Pascal's triangle, just like that. Pretty simple stuff. So if we do a harder question, like a plus b to the power of 6, we come over to the 6th row here, and we see that it has the setting out of, hold on, let me just get this here. We can see that it is 1 plus 6 plus 15 plus 20 plus 15 plus 6 plus 1. And you're probably thinking, well, how am I able to know how many powers of each a and b go in here? Well, if you imagine this as being a to the 6, b to the 0, the first pronumeral will decrease throughout the equation, and the second pronumeral will increase throughout the equation. So let's just see that here. So we have a to the 5, b to the 1, a to the 4, b to the 2, a to the 3, b to the 3, a to the 2, b to the 4, a to the 1, b to the 5, and a to the 0, b to the 6. So if we simplify this again, it becomes a to the 6 plus 6a to the 5b plus 15a to the 4b2 plus 20 a to the 3 b to the 3 plus 15 a to the 2 b to the 4 plus 6a b to the 5 plus plus b to the 6. So that is just the most simple theory I can give on how to do expansion at higher levels. Now let's apply this to an actual question. Say we have 1 plus 3y to the 4, right? Let me copy this down here so we can see it again. right? I'll just move it over there. We can see that it's going to be the power of 4, so 0, 1, 2, 3, 4, this row. So it's going to be 1, 4, 6, 4, 1, and there's going to be a plus because it's plus here. Let me just add these pluses in. There we go. So this is going to be 1, and then it's going to be 1 to the 4, 3y to the 4. Sorry, 3y to the 0. And then it's going to be 1 to the 3, 3y to the 1. 3y to the 1. It's going to be 1 to the 2, 3y to the 2. 1 to the 1, 3y to the 3. And then it's just going to be, hold on, I'll move this a bit down. Move this out of the way. Then we know it's going to be 1 to the 0 and 3y to the 4. So now all we have to do is expand this. So it's going to be 1 times 1, because 3y to the 0 is obviously going to be 1, plus 4 outside of 3y, plus 6 outside of 3y to the 2, plus 4 outside of 3y to the 3, plus 1 outside of 3y to the 4. So if we do this another layer down again, we can see that it's 1 plus 12y plus, this is going to be 6 outside of 9y squared, plus this is going to be 4 outside of 27y to the 3. That's going to be 81y to the 4. So again, we do this again, simplifying further more. 1 plus 12y plus 6 times 9, which is 54. Sorry, 54y squared, plus 27 times 4. You're going to need a calculator for some of these. Y to the 3, and then 81y to the 4. Now that is the completed solution for 1 plus 3y all to the power of 4. That is a simple overview for this topic of binomial expansion to higher powers. I would recommend remembering at least some of the basic principles of Pascal's triangle. Otherwise, I'm not sure if it's on the reference sheet that you get in the exam or not, but if in any case, I think it would be worth remembering some of these. Anyway, that is all I have for today. Be sure to continue following for the next uploads of math summaries for Extension 1 and Advanced. Thank you very much for tuning in. I will see you later.